Hello everyone, let's solve some Leetcode today. So today we have Leetcode 278, that is first bad version. So this problem has been phrased like a real world scenario in which you are a product manager and you are trying to lead a team. The team is basically working on a product. Now unfortunately the latest version of the product actually fails the quality check. And since each version is dependent on the previous version, if any version like V1 or V7 actually fails, all the other version or all the next versions will also fail. So if we had version 1, version 2, version 3, version 4, and in case the version 3 fails the quality check, the version 4 will also fail the quality check. And now the question is saying we have n versions which are numbered from 1 to n, and we have to find out the first version that was a bad one, which caused all the following ones to be bad also. Now we have been given an API that is called isBad version, which returns whether the given version is bad or not. And now we have to implement a function that will find the first bad version. And also we should minimize the number of calls to the API. So what the question is releasing is that we will have a bunch of version V1, V2, V3, V4. Let's just say V5 also is there, V6 is also there, V7. And now suppose V7 is the latest version which is failing the quality check. Now since V7 is failing the quality check, we have two possibilities. One is that V7 is the first bad version. Another one is that one of the versions from here, V1 to V6, was a bad version and that caused all the other versions after it to be bad also. So we have to figure out which version is the first version that caused all the versions after it to be bad one. If version 7 is the first bad one, then we will simply return 7 and we are done. Otherwise, we have to figure out which one is actually the first bad version from V1 to V7, because it can be any version, right? If V5 is bad version, then V6 will also become bad, V7 will also become bad. Similarly, V3 is bad version, V4 will also become bad, V5 will also become bad, V6 will also become bad, and V7 will also become bad. So we have to return the V3 because this will be the first version that was bad. So we will simply return 3 in this case. And now we have also been given this isBad version API. Now API here simply means a function, that's all, okay? We have been given this function just to determine whether the given version is bad or not, because they have not provided any information about the criteria for a bad version. So they are just providing us API and they are saying that, hey, just put the version in this function and we will tell you whether it is bad or good. Now we have a couple of ways to solve this question. We can actually go through and run a loop on 1 to n for all the versions. So we will have 1 to n and we can run this particular API, isBad version. So for each version, we will be checking if it is bad version or not. And the first time we find a version to be bad, we will simply return that version. We will not go any further. We will return the first bad version, simple. And now since in this solution, we are going from 1 to n, and checking all of these versions with the help of this version API, we may end up going through all the versions in the worst case. Because if the latest version is the only bad version, it will be the first bad version. And so all these will be fine, right? And then we will end up going through all the versions just to reach the end version. So in that case, the time complexity will be order of n, which is a linear time complexity. But hey, we can actually do better. We can do much better than this. Suppose that we have versions 1 to 6. And now we also suppose that the first bad version is 4. So if we actually try to create an array of whether a particular version is bad or good, then we will see something like this. 1 is not bad, so we will simply say false. 2 is not bad, we will simply say false. 3 is not bad, we will simply say false. Now 4th is the bad one. So we know that it is bad one. So the function or the given API will return true. It is a bad one. Then for this one also we will get true. For this one also we will get true because all of these are coming after 4th. So this question turns out to be something like this. Okay, we have to find out the first place where we get true. That's pretty much what we have to do, right? So how do we figure out the first place in an array like this where we find the true? Well, we can use binary search in this case. So I have written the indices of the elements here. Now let us have L and R. So initially L will be 0 and R will be 5. Now let us try to find the midpoint in this array. So we will have L plus R divided by 2, which is equals to 5 divided by 2, which is equal to 2. The integer division will be 2, not 2.5. So it means we will get this particular position, right? So mid will be here. And now we will need some conditions to figure out whether we should increment L or decrement R, or we should return this particular index to itself. So let's think about it. We are supposed to find the first place where we see the true, right? So just before the first place, we must have a false. So we will check if the current index is true, then we will check if the previous index is false. In this case, we don't have that, right? Current index itself is not true. So we know that the true will come after this F. So we will end up incrementing L. L will come here. Then we will check again M. So m will be L plus R divided by 2. So we have 5 plus 3 divided by 2, which is 8 by 2, which is 4. So mid is here. And now we can check, is the current element true? Well, yes, the mid element is actually true. Then what about the previous one? Well, the previous one is also true. That means we cannot really tell if this true, the previous one is the first one or not, because maybe there is another true right before it. So we don't actually have security, right? So what we can do is we can shift the R to mid minus 1, and the R will be here now. So as you can see that L is basically equals to R at this point. So it means we can stop our binary search. We have found the place where we will find the first true value. And in this case, we will simply return L, or you can also return R, but we will simply return L. So we basically have three situations that can happen. We can actually get the mid element as true and the previous element will be false. In this case, we know that this is the first true. So we will simply return the mid index. Mid will be returned. Now there is another situation also. What if we are at this place? We have the false here. Okay. Now what about the previous one? Well, we don't have to check the previous one, because if we are at the false, we know that we have to go ahead, right? The L pointer needs to be shifted ahead because the true will be somewhere in this direction. So we can simply shift the L to mid plus 1. So L will be mid plus 1. And now we also have a condition like this. Suppose that we get this position, and in this position we are actually getting true. Now we will check which one is the previous position, and the previous position is also true, but we cannot definitely say that this is the first true, because we may actually have another true here. And just how many times are we going to check? How many levels deep will we go, right? So we cannot just simply keep going and keep checking which one is the true. Otherwise that will simply become order of n complexity again. So we will make a decision based on this particular information only. If the current one is true, the previous one is also true, we know that the first true needs to be in this direction. So we will take the R and we will shift it to mid. This is the mid, so we will shift it to mid. Here we are shifting L to mid plus 1, and here we are shifting R to mid. Simple. And in this way, two things will happen. Either first we will find this M, the particular M, where we actually have the first true, and we will simply return the mid element, or we will end up completing the entire binary search, and we will have L double is equals to R. The L and R will be same, and we can simply return L at the end. And so based on these conditions, we will create a binary search algorithm. So now let us go through the code also. We have L equal to 0, R is equal to N. Then we are starting our binary search. And then in the binary search, we are running this only when L is less than R. So as soon as L becomes equal to R, we will end it and we will return L at the end. But in the while loop, we are first of all calculating the mid. So L plus R divided by 2, we are getting the mid. Then this is the place, okay, where most people might confuse. So this function has been provided by the question itself. So this function will be defined in the online judge anyways. So we can directly use it here. We don't have to create this function here. So what I'm doing here is I'm using this function and I'm passing the mid here to check whether the current mid is good one or bad one. It will return true or false. And so if this returns true, that means the current mid element is actually the bad version. Then we will check the previous one. So we will check if the previous one is bad or not. And if it turns out that the previous one was actually not bad, it means the previous one was actually false, then we will simply return mid here, as we already discussed in the drawing explanation. And then here we are checking the second condition. If the current version is bad and the previous version is also bad, it means we have the situation where we found two truths. So we are supposed to just shift the R pointer to mid. Otherwise, in every other case, we can simply shift the L pointer to mid plus 1. And these are the three conditions that we discussed in the drawing explanation. And so if we ever find the first true during the binary search, we will return it. Otherwise, at the end, we will return the L, because L and R will reach the first true after the complete binary search anyways. So now let us try to run it and see what happens. So yeah, it runs in 38 milliseconds and beats 48.74% solutions on Leetcode. So it's a pretty efficient solution. Now we can discuss the time and space complexity for this particular solution. So clearly the time complexity will be order of log n, because we are using binary search, and the time complexity for binary search is simply order of log n. Now the space complexity will be order of 1, that is constant, because we are only initializing the L and R and the mid variable, and all these three variables will consume a constant or a fixed amount of memory no matter how much the input size is. So n can be in millions, but this L, R and M will only keep consuming the same amount of memory, and so the memory consumption is basically fixed or constant, and that's why we are saying it is order of 1. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.